We will start graphing rational functions using translations. Before we begin, we need to talk about the translation. So a vertical shift, the constant is outside the function. So for instance, y over 1 over x plus or minus b, it's outside. Horizontal shift, the constant is inside. So for instance, you have to add or subtract a to x first. The reflection, negative is outside. So y equals -1 over x. And then shrinking or stretch. And for instance, we're going to be looking at shrinking, meaning that you are going to take the y-axis and push the y-axis together. The numerator is greater than 1, you shrink the y-axis. If you have a value in the denominator, so say like you have that, for instance, you can factor out a2, then that you would stretch it, but we don't look at those too much or at all. The parent graphs of this. So if you make a t-table when x is to the odd power, we will have points 1, 1, and -1, -1. These are the base points. And to sketch this graph, you will use the base points to move your graph. So we'll be at 1, 1, and -1, 1. You have asymptotes, and these asymptotes also move depending on, for instance, this horizontal asymptote will move vertically, and this vertical asymptote will move horizontally. So you need to move those as well. These are the base points that you will be moving, translating along with the asymptotes. So here is the parent graph to x to the odd power. And then the next one is if we have x to the even power. And the base points are 1, 1, and -1, 1. And we still have our asymptotes, which means that the graphs get really close to those lines, these axes, but they don't ever touch. So here's 1, 1, here's -1, 1, and it will kind of look like that. Okay. So this is x is of the odd power, x is to the even power. Reason why x to the even power, they're on the same side of the x-axis is because if you square any of these negative values, you get a positive value here. So let's go ahead and use these translations to graph some of these functions. And we're going to just sketch these. So y equals 1 over x plus 3 minus 2. So this parent graph, I'm not going to put in the asymptotes yet because we know that they are originally along or at the axes. So the axes will serve as those points. Now we will have a point here and a point here for our parent graph because remember they go swoop and swoop through those points. Okay, we're going to take each of these points This is an inside, so we are going to move left 3, and this one we're going to go down 2. The reason why we move left 3 is if you saw for x, it will equal 3, or what will create a 0. So, or if you've seen my other videos, remember the horizontal movement is opposite of what you want to think. So 1, 2, 3 will be this base point, and 1, 2, 3, oh, not yet though, will be here. Okay, but we still have to move down 2. 3, down 2. There we go. That one's a big no-no. And then we'll go 1, 2, 3, 1, 2. And then our asymptotes will actually be, so here's 0. We moved over -3. So the asymptotes are actually reflecting these. So we'll be at -3 for this asymptote, and we'll be at -2 on this asymptote. Okay, and it's really nice to know that, how you can find those new asymptotes by seeing those translations. Okay, so the next one, again, we will have our parent graph, and our axes will serve as our asymptotes. So here are the 2 base points. We are going to move right 1 and up 1. So 1, 1, and 1, 1. And then we're going to reflect these, which when we reflect them, and I can't see my graph real good. Let's see here. 1, 1, 1. That would be here, but then that would have to reflect. Okay, so these would have to reflect. So this one, oh, I know. Hold on, stop. Okay, sorry. I just found out an easier way to do this. Because I'm like, we have to reflect them, but that's kind of hard. So to reflect them, our base points are here and here, but our new base points will be on the other side. Okay, they'll be on the other side. So then we can go 1, 1, and 1, 1. There we go. And see, that's kind of hard to, I guess you'd have to reflect. You'd have to find the horizontal or the vertical asymptote and then reflect these across that line. But that's harder to do. So reflecting first and then finding, that would be a better idea. Reflecting and then moving. So we will have our asymptotes at 1 and +1 and +1. And then since this is a 3, we will shrink our graph. So they will actually be a little fatter, which is harder to show. I don't know, this part here will kind of bow out a little bit more. It won't be as, like, for instance, our parent graph, see, this bows out a little bit more, where our other graph was more almost an L shape with a round butt. Okay, so let's go ahead and I don't know, let's work another one of those. So here are the base points, but we're going to reflect them. So there's our reflection points. And we have to go left 4, 1, 2, 3, 4, and up 1. 1, 1, 2, 3, 4, and up 1. Okay, so then our value will be at -4 and +1. And then we don't need to skew it or anything, so this will be more of a L shape, just like that. So yeah, the easiest way to do it is reflect your points first and then move them. I was trying to move my points, then reflect them, and if you reflect them, so say you move these, well, this one would be here, so you'd have to reflect it across here, so the distance between your line and here would have to be the same distance between this line and your new point. So it is a little harder to come up with, so reflect them first. Okay, so here is our base points for this one. And if this were actually squared, the base point would be right here if it were squared. So, but right now we're just we'll work with our x. So we'll go right 3, 1, 2, 3, down 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. Okay, that's not like, oh wait, 1, 2, 3. It's actually supposed to go down here. If I had better graphs, you could see this better. But you get the picture. You post your parent graph points, which I throw them with x's, and you move each point. And then these horizontal and vertical places, or your numbers, that is where you're going to put your vertical asymptote and your horizontal asymptote. And then you're going to graph these just like that. So there's nothing to it on that one. When the translations are not this transparent, we will look at that on another video, because we have to work it a little differently and find our horizontal and vertical asymptotes a little bit better. But the translations, the vertical and horizontal values reflect our translations. So that's all for this video.